Welcome to the Bird Podcast. I'm Shobha Narayan. Today's guest is Dr. Umesh Srinivasan. Dr. Srinivasan and his team study how forest degradation combines with climate change to impact Himalayan biodiversity at multiple levels. They have been working in the Eastern Himalayas of Arunachal Pradesh, where they monitor bird populations in primary and log forests for a decade using mist netting and bird ringing. Welcome, Umesh. Thank you for being in the podcast.
Thank you very much, Shobha. My pleasure.
So we want to talk about your work, but prior to this, you were part of David Wilkoff's team at Princeton. Can you tell me about your work there as well?
Yes, when I was part of David's group, what we were trying to understand is how sensitive birds in the Himalayas are to temperature. And whether, if you go from the Eastern Himalayas to the Western Himalayas, do birds show differences in temperature sensitivity? So, for example, are there parts of the Himalayas where birds are more temperature sensitive than in other parts of the Himalayas, for instance?
And now your PhD work has to do with selective logging of birds in Arunachal Pradesh. Can you talk a little bit about that?
Well, certainly, selective logging is one of those forms of forest degradation that is very, very common and pervasive across the tropics. And it's a form of forest degradation, not a form of forest loss, where the forest is completely replaced by an entirely new kind of land use. So, for example, you can cut down a forest entirely and replace it with agriculture. But what selective logging does is it alters the structure of the forest, in that you go into the forest and you cut down a subset of the trees in the forest, either because they're large or the species are commercially important because they're good for furniture, for instance. And when you take out a subset of the trees from the forest, the structure of the forest is altered. The canopy of the forest, which is usually closed, then becomes open. Sunlight comes into the bottom of the forest floor, and the understory, which is the layer of vegetation close to the ground, suddenly proliferates and becomes much denser. So, selective logging, one, it's very common across the tropics. That's where most of the world's biodiversity is concentrated. And two, it has fundamental changes in terms of the structure of the forest. And therefore, it's likely to have very, very important effects on biodiversity across the world.
One of our podcasts interviews Dr. Sheshadri, who is also at your institute, and he was saying about how for shorebirds, the grasslands are very important. And if the structure there is changed into trees of the forest, that too messes up with the bird ecology. So it's similar to what you are saying as well. What is your current interest?
Uh, well, we're currently living through the sixth ever mass extinction on planet Earth. And the one obviously that captures our imagination is the one in which the dinosaurs went extinct with this huge meteoroid striking the Earth, a very dramatic event. But what we're going through right now, although it doesn't look as dramatic as, for example, the extinction of the dinosaurs, is no less intense. We're losing species are going extinct at about 1,000 times the rate at which you would see species going extinct, sort of as a baseline rate on Earth. And the two sort of biggest drivers of this biodiversity crisis, of this mass extinction, are climate change and the loss and degradation of natural habitats. So, what we are trying to understand is how does climate change and how does the loss of degradation of natural habitats impact biodiversity? How does biodiversity fare, especially when both of these things come together and jointly affect species? And we're especially interested in understanding these impacts in the Himalayas because it's a highly species rich part of the world, and a lot of the world's biodiversity is concentrated there. And the Himalayas is also warming thrice as fast as the global average and losing forests very, very fast. And so the impacts that humanity has on the world at large are also likely to be magnified to a certain extent on Himalayan biodiversity.
Um, can you concretize what you just said for us? For example, you said you use mist netting and ringing. Are there examples you can provide for people, non-scientists, for example?
So, what we're doing is tracking populations over time. And The idea is that we want to know, for instance, in primary forest that has never been disturbed versus log forest, which is, of course, degraded forest, what happens to the survival rates of birds? Do birds start facing higher mortality in log forest while they continue to do better in primary forest? So, what we do is we go out into patches of forest, uh, primary forest as well as log forest. And what we do is we use mist nets to temporarily capture birds, fit the birds with a numbered aluminium ring on their leg, and we release these birds back into the habitat. And it's a very, very common form of monitoring bird populations across the world. In fact, people in the UK even do it in their backyard. And, so what we do is we go year after year into the same locations, same patches of primary forest, same patches of log forest, and we look at in the same locations where we place the nets, are we getting recaptures of birds that we've caught in previous years, which would indicate that that individual has survived and remained in that habitat? Or are we getting a huge number of new individuals that we've never ringed before? And based on the number of new captures we get versus the number of recaptures we get, we're able to estimate the probability that a bird survives from one year to the next in a particular kind of habitat. And if you look at, let's say, one particular elevation, 2,000 meters above sea level, and you looked at primary forest at 2,000 meters and primary and log forest at 2,000 meters, then the trends in survival over time, for example, are species survival rates increasing in primary forest? Are they declining in primary forest? Are the declines of the increases in survival rates as fast in log forest? Or are the patterns completely different in log forest? That time component is because of climate change. So we have a component of land use change of forest degradation, which is primary and log forest at a given elevation, and that the populations in each of these two different habitats are also showing changes over time, and that's because of climate change. And so we're trying to understand how the survival rates are affected jointly by both climate change and by habitat degradation.
So, for a novice like me, it would seem that logged forests are not as conducive to birds as primary forests, or is that a different species inhabiting logged forests versus primary? What is the conclusions? What are the conclusions you've drawn?
There's a lot of variability in the way in which birds respond to selective logging. Some species, for example, love a dense understory. And so, selective logging, when it opens up the canopy and creates that dense understory, those species actually show increases in survival rates because the dense understory might be better for them to evade predators, or the dense understory might have more resources of the type that they feed on. So, there is a fair amount of variability across species. Uh, However, by and large, um, birds lose body condition in log forest, so they tend to become lighter. They tend to have lower body masses, so their body condition declines with logging, and their survival rates for most species also comes down in log forest compared to primary forest. So there definitely is, by and large, if you looked at it, if I were to summarize the effect that it has on the entire bird community, then logging, by and large, is detrimental to the bird community. And logging, the other thing we're finding is that logging can complicate the impacts of climate change. Log forest, on average, is about 2 degrees Celsius hotter than primary forest because the sun is just streaming in into log forest and warming it up. If you look at the maximum temperatures of primary and log forest is about 6 degrees hotter than primary forest. And 6 degrees is a massive jump in temperature. So if you have the same bird species in primary forest and an individual of the same species in log forest, the individual in log forest is facing a completely different temperature space compared to what its counterpart is facing in primary forest. And not only is that because logging in itself is causing increases in temperature, but it's also compounding the fact that temperatures are rising because of climate change. So they're rising faster in log forest than they would rise in primary forest. So all these things put together do have an effect on survival rates of species across these two kinds of habitats, disturbed and undisturbed.
And why do you think they lose weight? Why do you think the body mass goes down?
Well, we don't know for sure yet. One of the things we think is, for example, if birds eat insects, then logging causes a change in the type of insects or the number of insects that are available for birds. So, two birds, one in primary forest, one in log forest, both feeding for identical amounts of time, then the bird in log forest is going to get less for the amount of effort that it puts in than the bird in primary forest. On the other hand, if log forest has the same kinds of species and the same number of insect species that primary forest does, simply the fact that log forest is hotter might mean that individuals in log forest have to spend a longer time in the shade or a longer time immobile so that they don't overheat. So just the time available for them to be out and about finding the food that they need is might be less in log forest than it is in primary forest. Generally, less in hotter habitats than it is in cooler habitats, and that's something that we're pursuing now. And we hope to find out why the reason is that birds in log forest tend to have lower body conditions than those in primary forest.
You are operating in an area that is a dream for birders. And I know that I can see that you're looking through a lens across time and also across species. But just for amateur birders, tell us some birds that have fascinated you in the environments that you work in.
Well, it's been a dream for me for a long time as well, and I continue to live the dream. Sort of. Uh, uh, in the Indian subcontinent, the Himalayas are perhaps the richest, area in our country for sure. And within the Himalayas, the Eastern Himalayas are particularly species rich. And that's because you have so many babblers and warblers and flycatchers and robins and cats. And I'm particularly fascinated by babblers, in Eagle Nest Wildlife Sanctuary, which is the location where I work. Um, we've got about 90 to 100 species of various kinds of babblers. They're all called by different names, of course, falvettas and euhenas and minlas and sibias, but generally there is babbler guild. And they're a fascinating set of species, very active, bustling around all the time, often very vocal. And amongst the babblers, the wren babblers have a particular fascination for me. We have 8 species of wren babblers in Eagle Nest, all of which are very secretive, very skulking. So you hear them far more often than you see them. And even the natural history of these species was unknown until recently. You flip through even the Handbook of Birds of India and Pakistan by Ali and Ripley, and you get to the page of the wedge-billed wren babbler, and it would say something like habitat unknown, song unknown, elevational movements unknown. So you have one specimen from Bhutan sometime in the early 1900s. And these, when I was growing up and getting interested in birds, these were sort of mythical species for me. And so, like I said, I'm continuing to live the dream. I never imagined that I would be studying these species for basically my livelihood. So it's fantastic.
What about Sikkim and Uttarakhand, which is also where? So it seems to me you like social birds that are in groups and they are very talkative. Is it true in Sikkim and Uttarakhand, which is also where you work? Are there other birds that fascinate you there?
Uh, well, Sikkim and Uttarakhand, of course, is the Himalayan bird fauna, which anywhere in the Himalayas that you go, it's absolutely brilliant. It's so exciting to be out in the field and to look at these birds. What happens in the Himalayas is when you go from the east to the west, if you go from Arunachal all the way to, let's say, Himachal, there's quite a drastic decline in the number of bird species that you see. And a lot of these babbler species in Arunachal actually drop out as you go further west. So Himachal has very few babbler species compared to Arunachal. But what is that's replaced by is a diversity of pheasants, things like cheer pheasant, things like koklas pheasant, um, a number of warbler species. I just love babblers and warblers. Those are two of my favorite groups. And anywhere in the Himalayas, be it Sikkim or Uttarakhand or Arunachal, if I'm out in the field watching birds, then I'm happy. Yeah.
it occurred to me after I asked the question that it was sort of a silly question to have state borders or even locational borders drawn by humans for birds, because their sense of borders are very different. But you're saying that from Uttarakhand to Arunachal, the pheasants, the birds have a different sort of borders, because you just said that you see different sort of birds in different locations. So it's more altitudinal. And what else would you say would be the reason for
So,
the
one,
change?
so one would be that a lot of the birds of the Himalayas actually have a Southeast Asian origin, or a South Chinese origin, in fact. So the mountains of South China are thought to be where these birds evolved. And the Himalayas being a relatively young mountain range, after they were pushed up and formed by the collision of the Indian plate with the Eurasian plate, uh, it was then that they were colonized by birds coming in from the east and moving further towards the west. So, one of the reasons we think for the decline in bird species richness, or the number of bird species that you see as you go westwards, is simply that different species have moved to different extents towards the west. And that could be for a various number of reasons. For example, some birds might be better dispersers. They're able to use a variety of different habitats. They're able to fly better or stronger flyers, and therefore move further west than other species. The other thing is that within the Himalayas, you see this very strong temperature gradient. The Western Himalayas are more temperate than the Eastern Himalayas, which tend to be more tropical. So if you just look at annual temperature variability in the East and the West, the East is half as seasonal in terms of how variable temperature is within a year than the West. The West is twice as seasonal as the East. It's much colder in winter, warmer in summer. And so the species that are able to colonize these Western Himalayan areas or Western Himalayan habitats have to be able to tolerate that variation in temperature. And so they need to be more thermally generalist compared to species in the east where the temperature doesn't vary all that much. So even if I'm a bird and I'm a thermal specialist, I would be happy in the Eastern Himalayas, continuing to inhabit those kinds of habitats. But I would be in trouble if I tried to move further west and occupy an area that's really cold in winter and very warm in summer. So we think that gradient in temperature seasonality has also had an effect in influencing which birds are able to move from the east to colonize the Western Himalayas.
One of our guests in this podcast is an author called Jonathan Mayberg, who has written a book on the caracaras of Chile. And the term that he also uses about which birds survive, or he says, for example, that falcons like peregrine falcons are specialists, whereas the caracaras are generalists. And lots of scientists like you use this the specific term. Now, is it linked to survival? For example, would you say that temperature generalists will do better with all the degradation that's happening, or temperature specialists? Is there any link? Is there any causality or correlation that you can find?
Well, I would say all else being equal, if you had a temperature specialist that is restricted to a very narrow range of temperatures where it can survive and reproduce and maintain its populations, and you have a temperature generalist which can tolerate and survive and reproduce in a much broader range of temperatures, all else being equal, the temperature generalist, especially in today's world where the globe is heating up so fast, the temperature generalist would certainly be at an advantage compared to the temperature specialist. On the other hand, it's a little more complicated than that. For instance, especially in tropical mountains, birds tend to be temperature specialists. They tend to have narrow temperature niches or narrow areas of temperature that they can survive in. And what's happening with global warming in tropical mountains, where species tend to be thermal specialists, is that as the mountain warms up, temperatures move up. So if you had 20 degrees Celsius at 200 meters in 1980, today 20 degrees Celsius might be at 1,000 meters, simply because the earth has warmed and those temperature bands are also moving up. So the thermal specialists would be forced to move further up the mountain to remain in the kind of climate temperature envelope that they are best suited to. Whereas the generalists might not need to move at all, or they would need to move at a much slower pace than the thermal specialists. Now, if you have large areas of primary forest that have never been disturbed across entire mountain slopes, right from the foothills of the mountain to right to the top of the mountain, no disturbance at all, then the thermal specialists might actually be able to move in response to climate change, shift their elevational distributions, and continue to do well at a different elevation. So they shift their ranges, but they're able to survive in those new ranges. Whereas for a thermal specialist that's moving up the mountain and then suddenly faces a belt, let's say, of agriculture, of selectively logged forests, primarily habitats that are either much hotter than primary forest or much more variable in temperature than primary forest. So, agriculture, for example, can be 13 degrees Celsius hotter than primary forest. It's also much colder at night in agriculture and much hotter in the day. Whereas if you go into a primary forest, the canopy has a buffering effect. So it's cooler than during the day and warmer during the night. So for a bird that's evolved in a habitat like that, like a primary forest, to suddenly move up because of climate change and enter into agriculture is going to be very, very likely a situation that it cannot cope with and cannot survive. So, as long as uh, there are vast tracts of primary forest connecting all these elevations, it's possible that even thermal specialists might be able to shift their ranges and continue to survive in the face of climate change. But that's only to up until a particular level of climate change, right? If the climate warms beyond that, what happens is, and there's evidence for this, is that birds just reach the top of the mountain, run out of space, and then go locally extinct because there's nowhere up to go, nowhere further up to go. So it depends on a whole lot of variables, but all else being equal, to come back to your question,
Hmm.
uh, thermal generalists would be at an advantage compared to thermal specialists
Yeah.
when it comes to climate change.
Yeah, we did an episode on the Great Indian Bustards, and the sad thing is, all these birds that have evolved so wonderfully over millennia are now forced. For example, the bustard doesn't know how to deal with windmills that are in their habitat. It lays eggs on the ground, and now there are cattle herders, the cows. So I was just thinking, after listening to you, it seems like the birds will shrink to a select group of very adaptable birds and we will lose all else. Is that too pessimistic a view?
Well, we're already seeing that happen in any place where you have any kind of human disturbance. So when we convert, for example, forest to agriculture or forest to cities, you're left in the cities or in agriculture with these highly adaptable species, and that's a process called biotic homogenization, where you go across the world or you go across a series of habitats, and any disturbance in the habitat leads to these generalist species coming in, occupying these disturbed habitats to the detriment of species that were specialists in those habitats. So you do see that happening. This biotic homogenization happening regardless of the kind of disturbance we're talking about. Selective logging, habitat fragmentation, agriculture, grazing, and so on. They tend to have similar effects. But what's interesting, and this is some of the work that we have been doing in the Himalayas, is that we know that the Western Himalayan birds are far more thermally generalist than the Eastern Himalayan birds. They're generally found in habitats that are much more seasonal, and those populations are adapted to that seasonality. They're adapted to a much broader range of temperatures. So when you convert forest to agriculture in the Eastern Himalayas versus the Western Himalayas, you can see very, very different impacts on the bird community. The number of species that can tolerate agriculture in the Eastern Himalayas is very, very low. So, agriculture causes a drastic reduction in the number of bird species compared to forest. Whereas in the West, a lot of species are actually able to continue inhabiting agricultural lands. They're thermal generalists, and they're able to deal with the new thermal context of
Yeah.
these agricultural lands. So even within the Himalayas, we tend to think of, let's say, Himalayas and the Himalayan birds as this one sort of homogeneous entity.
Yes.
And whatever holds true for one part of the Himalayas will hold true for the rest of it as well.
Yes.
But that's not necessarily true. And so we do see these very, very different responses of bird communities depending on what kind of temperatures they're at, depending on what kind of rainfall regimes they're at, and so on.
Yeah.
It's not just the species differences that we're talking about, it's even populations of the same species. So if you have Great Barbet, for example, that's found across the Himalayas, but the populations of Great Barbet in the west seem to be able to tolerate a much broader range of temperatures than the populations of Great Barbet in the east. So even within a species, populations in the west can be thermal generalists and populations in the east can be thermal specialists.
That's so cool. Tell us, for people who haven't seen the Himalayas, how much of primary forest is left over? If you can describe the situation there.
So, I've been working in Arunachal for the last 12 years, 15 years. And I'm most familiar with, of course, Arunachal, not very familiar with the Western Himalayas as much. But, the Western Himalayas have lost a lot of forest at the lower elevations. So from the foothills to about 1800 meters, there has been a huge loss in forest cover. And that's largely because of the replacement of forests with permanent agriculture. Um, but population densities in the Western Himalayas are also much higher than population densities in the Eastern Himalayas. And even the remnant forests in the West, in many parts, face a lot of pressure because of fire, because of grazing, because of lopping of the trees for fuel wood. So even the remnant forests are under pressure and they're being degraded because of various reasons in the West. In the Eastern Himalayas, generally population densities, human population densities, are very low. Arunachal, for example, has something like 17 or 20 people per square kilometer, which is a very, very low population density. And a large part of Arunachal is covered in forest. Almost 80% of Arunachal is covered in forest of some kind or the other. So, we have a lot more forests in the east than we do in the Western Himalayas, and that's for sure. But forest degradation is ongoing in the east as well. Forest loss is ongoing in the east as well. Um, and we've lost a fair amount of the foothills forest in the east, in the foothills of the Himalayas in Arunachal Pradesh. But we're also, this is very fascinating because the Himalayas are not like a cone. People tend to think of mountains as a cone. And as you go up, the amount of space available reduces because of the slope. But the Himalayas are not like that. They're actually, very, very steep from the foothills to about 1800 meters. They become much less steep from 1800 meters to about 2400 meters and then rise sharply again. So this band of land between 1800 and 2400 meters is very conducive for settlement. It's very conducive for agriculture. It's the terrain is much easier. It's much easier to settle in and farm. And so you do see in many parts of Arunachal this band in the middle elevations where agriculture is now permanent, where the settlements are, where the densest human populations are. And that's sort of a threat for the birds because if you have these low elevation birds coming to these higher elevations from below, moving up in response to climate change, they might suddenly be faced with this ring of unsuitable habitat, which might compromise their ability to keep moving further up and remain resilient to climate change.
I want to end with a question which has to do with optimism and pessimism. How optimistic are you for the birds in the Arunachal Pradesh, and what are some things we can do to reduce the bleak picture that all of us know about with respect to human impact on the birds. So tell us a good story and a bad story, I guess. It's a good.
Well, I think the bad story is actually quite horrific, especially when it comes to climate change. We're already a degree Celsius warmer on average, the entire Earth, than it was in the 60s. Uh, and the pace is not abating. In fact, it's becoming even hotter and hotter. And that solution, of course, the solution for climate change is far removed from even individual governments. For example, it requires cooperation at a scale that is, across countries, across continents. The entire global community has to deal with climate change. But I think there are certain things that we certainly can do, especially the Eastern Himalayas, where a large proportion of the forest cover is still intact, um, and we can do quickly. And one of those things is to make sure that we do protect large tracts of forest that span elevational gradients. We should not be left with a situation where we have patchy little forests, areas that are very, very well protected, but there's no connectivity between those forest patches. So, for species to remain resilient to climate change by moving up or moving their ranges to adapt, connectivity is very, very essential. Um, and this is something that some of us, a much larger team, a team that involves scientists in the forest department, graphic designers, nature educators, cartoonists, and have been working with the Bugun community of Arunachal Pradesh to try and protect this critically endangered bird species called the Bugun Liochicla, the global population of which, as far as we know, and people have searched for it quite intensively. As far as we know, the global population is about 20 individuals, which is restricted to a roughly 2 square kilometer area, which is entirely on the lands that are managed by the Bugun community of the Singchung village. Uh, and we've been working with them for a long time now, and very hearteningly, they actually put apart a large uh, proportion of their land to actually protect both the Bugun Liochicla and a whole variety of other threatened Himalayan biodiversity that is found on their lands. And that area spans a pretty large elevational gradient. So, there are uh, a lot of positives and there are opportunities, especially in the East, where, tribal communities have been managing these forests. They have ownership of these forests, and they certainly with the Bugun community, it's amazing to see the sense of pride. That the Bugun Liochicla is named after their community. That sense of pride and that sense of ownership, and it's very, very heartening to see these kinds of efforts where species are protected for the sake of protection, and not necessarily because there's any
Aim to be
other
had.
right. Exactly.
Yeah. Any last words? I want to end on that very heartening note where, as you say, climate change is a big problem, but there are small things that the human community can do to save some species that deserve to be saved.
As a scientist, we try, or our group at least, tries to do work that can have potential application in the future in terms of informing us about how best to go about protecting natural habitats, what are the natural habitats that need to be protected, how much disturbance is still okay for biodiversity to be able to hang on. Uh, but, you know, and that's important. I think it's important to show, for example, that species are moving up with climate change, And in the absence of research and absence of people actually going out and trying to understand this, we wouldn't necessarily be able to. We wouldn't know these things until it might have been too late. But I think the most important thing at this point is that we need to protect the little natural habitat that's left to us. And the natural habitats, and that we know already, we don't need science to tell us that, you know, only 4% of India's land is protected. And if we've not been able to solve all the problems of India's, food security and population growth and so on, using 96% of our land, it's very unlikely that you're going to convert the rest of the 4% and then make some huge difference to uh, to the country. So it's important to protect that land, because if at all there is a kind of habitat that will serve as a buffer to climate change, it will be natural habitats. And if at all there's anything we can do to enhance the value of these natural habitats for species dealing with climate change, it would be connectivity, and to make sure that natural habitats are connected to each other to enable species to move.
On that note, Umesh Srinivasan, thank you for being in the Bird Podcast.
Thank you very much, Shobha. My pleasure, absolutely. Thank you.
Bird Podcast is produced by Ullas Anand and Echo Edu. I'm Shobha Narayan. Thank you for listening.